So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 7 of the June daily Leetcode challenge, and we again have a medium level question in front of us. It's something very different from what we have seen till now in the June daily Leetcode challenge. This will be a really interesting one, and you will learn a totally new topic here called bit manipulation. Okay, so let us see what it is. It's question 1318. Minimum flips to make A or B. See this, what is this, or we will talk about it in details. But just understand one, there's some operation happening here. Okay, A or B equals to C. Okay, so what? First, see the inputs. We are given three numbers in the inputs. Okay, they're integers, and three variables which are integers, right? So what we are given is given three positive numbers A, B, and C. Return minimum flips. Okay, minimum flips. What is flipping here? Basically, see, we are talking about bit manipulations here. So when we talk about a bit, when we talk about a bit, flip means reversing it. That means if it is zero, flipping it to one. If it is one, flipping it back to zero. That is what is called flipping. Okay, return minimum flips required in some bits. See, ultimately they have now given this hint. We are talking about bits here. Okay, return the minimum flips required in some bits of A and B to make A or B equal to C. Okay, what they're talking here is we are going to do a bitwise or between the bits of A and B, and we will need to get it in done in such a way that it matches every bit of C. Okay, that's what it is, and they have given here also bitwise or operation. Okay, flip operation consists of change. See, they have given the definition here. What is a flip operation? Okay, it consists of change of any single bit one to zero. Okay, see, if it is one, it will become zero. That is basically if it is zero, it will become one. That is a flipping. Okay, in binary representation. Okay, that is basic idea. Now let me come to this. If you are a beginner, if you don't know anything what is being discussed here, do not worry. We will be talking in detail. See, this question is basically easier side, but we will be spending most of the time in understanding what is happening here in the bitwise operations. If you're new to this topic, then you have arrived with the right area. Okay, so let us begin. See, every number, when we say 5 or 4 or 3, in computer how it is stored is, you must be knowing it, in zeros and ones. Okay, every number is stored in form of zeros and ones. Okay, for example, see, this is 5. Okay, a equal to 5, it is stored here as 101. Okay, in the memory of a computer it will be stored in forms of zeros and ones. One refers to high voltage, zero refers to low voltage. Okay, and that is how it is stored. Okay, computer only identifies these things. It doesn't know what is 5 is. Okay, 5 is a stored as a binary one. Okay, so that is the basic idea. For example, now how do we get to know that 101 represents 5? Okay, because see, every power, it's basically, for example, when we talk about decimal, okay, the unit place refers to 10 power 0, the ones place refers to 10 power 1, and so on, right? Similarly, this is binary. That means every power has a value of 2, okay? So the unit place will be 2 power 0, the first place will be 2 power 1, and the second place will be 2 power 2, and so on, okay? So how to get the number? See, this place refers to 2 power 0, that is 1, okay? This place refers to 2 power 1, okay? It is 0, so nothing. This place refers to 2 power 2, okay? So 2 power 2 into 1 plus 1, okay? That is 4 plus 1, 5. That is the basic idea, friends. I will again repeat. See, it is of the form 84210. Okay, what is 8 to power 3? What is 4 to power square? What is 2 to power 1? What is 1 to power 0? And so on, right? So 84210. Okay, so yeah, that is the basic idea, friends. And see, these things, I'm because I have to cover this video in a limited time frame, so I will be touching each topic, just I will give you some hints, but in a detailed way. If you want to understand, we will have to, these are very simple things. You can also learn it on your own, right? You can just google it once and you will get so many examples. So I have given you a hint. When we say binary representation, it basically means converting into from decimal number system to a number system in binary, where each value has a power, like each value has a power which is related to 2. Okay, that is the basic idea. And now coming to bitwise operations. Okay, now you, as you can see, let me zoom it further. As you can see, 5 has these things. Okay, similarly, 1, if you talk about, see, what is, how to get 1? See, 1 is anything raised to power 0, right? So this is how it is written. Okay, 0 comes 0 1. Okay, this place refers to 2 power 0, so 2 power 0 into 1 is 1. Okay, now we will do some bitwise operations between 5 and 1. Okay, 5 is represented by 101, 1 is represented by 001. Now we'll see how the bitwise operation works when we talk about, when we take these numbers into consideration. Okay, now comes the AND operator. Okay, how AND operator works? If, see, if first bit is 1 and second bit is also 1, it refers to 1. Okay, so I think these things you will be knowing because you will study them when you know if you are taking a basic course in CS. So 1 basically refers to, If let me quickly review. If 1 and 1, it will be 1. If 1 and 0, if any 0 is present, it won't be 1. Okay, that is the basic idea. Okay, so 1 and 1 only will lead to 1. Rest all the cases, for example, 0 1 1 0 0 0, all these things will lead to 0. That is the basic idea. And if you see in this example, okay, this is 1, this is 0, so the answer in this case, yeah, is 0. Okay, similarly, this middle is 0, this middle is 0. So here also 0. Okay. And here it is 1. This is also 1. So it reversed. It came and 1. Okay. So the 5 and 1 is 1. Okay. Now coming to OR. OR is the somewhat reverse of AND. What it means is even if a single 1 is present, the answer will be 1. Okay. That is the basic difference. So you can see here 1 is present here. Okay. And 0 is present here. As I said, even if a single 1 is present, the answer will be 1, and it's happening like that. Okay. Rest both the cases are same. Okay. Rest middle and the last bit is same. Okay. So the answer here is 5. So 5 or 1 is 5. But 5 and 1 is 1. Okay. Now comes the XOR operator. What XOR means is that basically if both the values are different. Okay. For example, 1 and 0 or 0 and 1, if both the values are different, it will lead to a 1. Okay. If both the values are same, it will lead to a 0. For example, here see 1 and 0 are different. Okay. That means it will lead to 1. Okay. If this, now see that this case 0 and 0, okay, both are same. Okay, 0 and 0 both are same, so it will lead to a 0. Similarly, 1 and 1 both are same. Okay, 1 and 1 both are same, that's why it will lead to 0. XOR basically means if for example I'm doing OR between A and B, so for example the unit place of A and unit place of B, that means both of them should be different, only that it will, only then it will lead to 1, otherwise it will lead to 0, right? So these are some of the bitwise operators. Now we'll talk about shifting. Okay, what shifting means is that we have two types of shift: left shift and right shift. Okay, you can see here right shift is indicated like this: right shift by 1. Okay, and then this is the left shift by 1. Okay, so what is right shift basically? See, you are seeing some values here, right? If I right shift them by 1, okay, please imagine yourself how it will be if I right shift them by 1. Okay, here in this case right shift, what means is the ones in the units place will be lost. That is the basic idea. If I right shift by 1, something in the units place will be lost. For example, this particular number, okay, I am going to right shift by 1. So what will happen is the units place number will be lost, and we are only remaining with the rest of the numbers, which is 1 and 0. Okay, if you take the value of this in decimal form, it will lead to a value of 2. Okay, because see, 0 is refers to 0, 2 power 0 place, 1 is in 2 power 1 place, so 2 power 1 into 1 is 2. Okay, that is the basic idea. And if you talk about left shift, okay, basically we won't be using left shift in our particular this particular question, but I will quickly show what it is. See, 101 left shift, what will happen is, as you can imagine, a new bit is getting added in the right side. Okay, see, it was 101, now it become 1010, so this new bit got added because we left it by 1. Okay, so by now you would have understood, if you do a right shift, we are losing a bit, but if we do a left shift, a new bit is getting added at the right side with the value 0. Okay, if you take this value, okay, so this refers to the 8 2 power 3 place, this refers to the 2 power 1 place. Okay, so 2 power 3 plus 2 power 1, what it is, so 8 plus 2, which is 10. Okay, so this is 10. Okay, so basically I have explained all the possible operations, but a bit faster way I explained you. You can just pause this video or play it slowly, and just understand it by yourself once. Okay, replay it and understand by yourself once. Okay, now coming to the most important part: what is LSB and what is MSB? Okay, least significant bit and most significant bit. Okay, the rightmost bit is called the least significant bit, and the leftmost bit is called the most significant bit. Why it is like that? Because see, it will refer to a bigger power of 2. Okay, so the value matters a lot on this. Okay, so that's why it's called the most significant bit, and the rightmost is called the least significant bit because it refers to the slowest, smallest power of 2. Okay, so now coming to now this thing. Okay, so whenever we want to get the LSB of a number, okay, for example, A is a number like this. Okay, A is a number like this. I want to get its LSB. Okay, what I will do is I will do AND with 1. Okay, why 1? See, 1 is a like this. Okay, whenever you do AND with 1, okay, you will get the LSB of A. Okay, how you will get? For example, see here, we are doing 5 and 1. Okay, so because see, these numbers are 0. Okay, as you know, when we do AND, even if a single 0 is present, it will lead to 0. So these numbers, whatever is present here, will anyway be eliminated. Okay, whatever is present here will be eliminated. Only the last bit of A only will matter here. If it is 1, you will get 1 here. Okay, if it is a 0, you will get a 0 here. That is the basic idea. Okay, that's why A and 1 gives the LSB of A. Okay, this we are going to use. Okay, this is the only thing which we need. Okay, here. Okay, now coming to today's solution. So as they have mentioned, we are going to do A or B, okay, and we have to find which bits to change, okay. Minimum flex required to make A or B equal to C. So we're a reverse engineering here, okay. We'll start with C, okay. If the LSB, see, as I told you, we'll go bit by bit. The idea here is C. First, we will deal with the leftmost bit, okay. Sorry, the rightmost bit, which is called the least significant bit, okay. Once we have dealt with it, what we'll do is we will right shift each of them, okay. We will right shift, as we saw here. When we right shift, what happens is, see, this one, see, whatever is in the, see, first I have dealt with the LSB. Okay, this is the LSB. Okay, then I will right shift it. What will happen in the right shift? In the right shift, this LSB will be eliminated. So we'll get the next number, which is next to the LSB. Okay, now this will become the LSB. That is the basic idea. So that is how we are going to get each of the numbers here. Okay, we will use that number, we'll manipulate it, then we'll right shift it to get the next number. That is the basic reference. So as I'm saying you, we are going to use the reverse engineering. We'll start with C, okay. If C has a 1, okay, C has a 1, and we are doing our operation between A and B to get this. So what are the possibilities? Okay, either A or B both have 1, or any one of them have 1. Okay, that is the basic idea, right? If that is the case, we don't need to make any change. Okay, so that's what we are checking. If either, see, that's why we are using OR. Okay, we are using OR here. Okay, either A has a 1 or the B has a 1. See, this refers to the LSB of B. Okay, this refers to the LSB of A. Okay, if LSB of A or the LSB of B have a 1, then no need to make any change, because anyway we are going to get 1 in the LSB of C. That is the basic idea. So whenever this happens, I'm not getting anything to my answer. Okay, so no flips required. But if this is not the case, okay, that means both LSB of A and LSB of B are 0. In that case, it is not possible to get 1 in LSB of C. Please understand, friends, this you require the knowledge of AND operator here, bitwise AND. So if you're not sure what is bitwise AND, please either refer to my video, as I told you in the beginning of this video, or you can simply Google it somewhere and you will get the answer. Okay. See, if I am doing OR operation and I have to get 1, there are only 3 cases. Okay, either both A and B are 1, or one of them is 1. Okay, so A is 1, B is 0, or B is 1, C is 0. Oh, sorry, B is 1 and A is 0. Okay, these are only 3 cases. The fourth case is both A and B are 0. In that case, we are not going to get 1. Okay, so in all the 3 cases, we will come to this part. Okay, no need to make any flips. In the fourth case, where both A and B are going to be 0, we will come to this case where we are going to add 1. Okay, so we require any one flip. Okay, one flip in either A or B. Okay, any one of them, we just need to make a flip. So if both of them are 0, we just need any one of them to be 1. Okay, that is the basic idea. Now coming to the else case. Okay, this was the case when LSB of C is 1. Okay, now coming to the case when LSB of C is 0. C is 0, and we are doing OR operation. Okay, so in this case, as you know, whenever we do a OR, if any single one is present, the answer will become 1. Okay. So here we are checking if the LSB of A is 1. If it is 1, we will need to change it. Okay. And similarly, we are checking if the LSB of B is 1. If it is 1, again we will need to change it. Okay. So that's why I'm adding the 2. Okay. I'm adding the 2 and I'm adding it to my answer. Okay. So if my LSB of A is 1, I will have to change it. If my LSB of B is 1, I will have to change it, because LSB of the answer, which C, is 0 here. Okay. So I will have to add it to my answer. Once I have done this processing, and now I will be moving to the bit left to my LSB. Okay, how to get that? To get that, I will do a right shift. As I've told you, I've already explained, see, everything in detail. See, whatever you need to solve this question is present in this particular page here. Let me tell this thing very, very frankly. I might have explained them in different parts of the video, but everything you need to solve this question, or if you are not don't know anything and you want to solve this question, then also everything is present here. You just need to understand it and link what is what. Okay, so this is what is right shifting means. Right shifting means the LSB will be eliminated. The bit which is left to the LSB will now become the LSB. Okay, so that is what is happening here. Okay, now this thing will again continue. Okay, see, what is the condition I have given here? Till any one of them is 1. Okay, okay, see, till all of them are not 0, this will be executed. That is the basic idea. Okay, till all of them are not 0. Yeah, then that will be happening. And yeah, yeah, friends, so this thing will continue till we are going through each of the bits, and once all of them are dealt with, so both A, B, so all of them A, B, and C will become 0 after that. Okay, so yeah, that is the basic idea, friends. And yeah, as I already mentioned, how the right shift is working. After right shifting A to the right, after right shifting A to the right, A and 1 will represent the second significant bit. Okay, second least significant bit. Okay, the second LSB. That is the basic idea. And finally, after calculating all the things, answer will refresh this answer, it's an integer and it counts for number of changes required. Okay, that is number of flippings required, and finally we return that answer. I'll just quickly run and show how it works. You can see it's clearing all the test cases. And yeah, friends, that was all for today. So this question is regarding a bit manipulation. You will have to learn what is AND operator, what is the OR operator, and what is XOR operator, and then right and left shifts. Okay. Uh, as you might be knowing, the right shift, decreases the value of a number. It, leads to the one loss of a bit. Okay. Similarly, if you talk about left shift, it increases the value of a number, but the bit getting added is zero. Okay. But the bit, now you will be thinking how the value increases if the bit getting added is zero. See, the bits are, sent left side to, yeah, see, for example, this one was at the place of, see, 2 power 2. Okay, but after left shifting it went to 2 power 3. So that's how the value is getting bigger. Okay, so yeah, friends, that was all for today. I will again repeat what we are doing here. We are taking each bit, we are analyzing it. Okay, and then we are shifting it to the right to expose the second LSB, and then we are again continuing the same with the second LSB. Okay, we are manipulating it and we are calculating the number of flips required. So yeah, friends, that was all for today. If you have understood, please do comment below. And I think there is no other possible. See, you can solve this question using XOR also. I have not used XOR in my answer, but you can also use XOR. Okay, so that is the only thing which I wanted to mention. And yeah, friends, that was all for today. Thanks a lot. See you tomorrow.